Okay, so now we're going to be looking at calculating the velocity and acceleration, or the speed and acceleration, for our polynomial function. Now, the polynomial function is by far the easiest one because you're already given, or you've already calculated, the time and the distance, which is something you're going to have to do with the other ones because you've only got the function. So, I'm going to say that my function for the displacement is going to be 0.288225 t. Now, my first step that I'm going to do is I'm going to calculate the derivative of this function. So I'm going to have dt all over d bracket d dt. So that's this one on the top and this one on the bottom. If you want to change to using x's and y's, you can do that as well. So now that I'm going to calculate the derivative of this with respect to x, that means I'm going to calculate the derivative of this function with respect, not x, to t, bracket 0.288225t, which is going to leave me with d t over d bracket d t bracket as just being 0.288225. Okay, you might just choose to write that as d air comma thingy t. Okay, so what it's really telling me is because my function here is linear, that means that it's going to have constant speed. It's going at the same speed the whole time. So next thing I'm going to fill in is a little table. So in your assignment, you should have a table that's got the time and the distance, and then your next one is going to be a table that's got the time and the speed or the velocity. I'm going to call it VT. Or you could also write T, comma, or D, comma, T, whatever one of these makes you the happiest. Okay, so at the top there, you're going to have your times. Now, you're going to get your times from up here. Whatever you put into Desmos is what you're going to be putting in these sections here. So the first one will be 0. And at that 0, my constant speed for this function is 0.288225. It's also the same at 5, or whatever my next time period is, 17 point something seconds, is still 0.288225. Now, if you've chosen to use your polynomial function, it means that you'll have a linear function down here. So if I had a linear function down here, I would be substituting these values of t into this part here, and then my answer for that would go underneath in the table. Once I've worked out my speed values, now I'm going to look for acceleration. So I'm just going to get rid of this section here. Okay, so to work out my acceleration, I'm going to work out the double derivative. So I'm going to take the derivative of my speed function. So now I've got d t over d dt like that. This one's squared, that's got a squared there. Maybe that's the other way around. Check that notation for me before you put it in your assignment. Actually, I think it is the other way around. I think the squared goes here. Double check it before it goes in your assignment. Okay, so that means that I'm going to calculate the derivative with respect to t of our function 0.288225, which is going to leave me with 0. Now, this makes sense because we've got constant speed, which means it's not accelerating or decelerating. The other thing that you need to think about when you are talking about this in your assignment is, does it make sense for somebody running a marathon to start with speed? Or should you be starting stationary? It doesn't affect your calculations. It's just something that you're going to need to consider.